everyone, welcome to MBAP's video series of conceptual lectures. And today the topic that we will be taking up is it's essentially three subtopics: ratio, proportion, and variation. All right. So the agenda over here would be to cover the basic concepts that are present in ratio, proportion, and variation, also certain questions, and we'll also look at actual questions which have been asked in previous examinations like CAT, SNAP, and FMS. Okay, so with that, we'll start with the concept with ratios. All right, now in ratios, the basic way to understand actually is that let's just assume that there is a straight line of 100 centimeter. Okay, and if I say that I have divided this line into a ratio of 2:3. Okay, there is a 10 centimeter 100 centimeter line I have divided into ratio of 2:3. So that means this doesn't mean that this part of the line is 2 centimeter and 3 centimeter, which usually the students actually get confused with. It essentially means that this line, this part is going to be 2x centimeter. The actual value in centimeters, the actual length will be 2x centimeter and 3x centimeter. Okay, and when I add these two parts, I get my entire 100 centimeter line. So this becomes 2 plus x 3x, which is 5x, which is also 100 centimeter. That means the value, this common multiple is coming out to be 20. So if I want to find out the actual lengths of these two parts, it will be 2 into 20, which is 40, and 3 into 20, which is 60. So see, when you add them, you again get 100 centimeter. Alright, so this is essentially the meaning of ratios. You will always consider them to be as part of a multiple, common multiple, 2x and 3x, and then you will try to equate it with the actual total value. Okay, now there is one more thing that you can do over here, is that if I just wanted to, I didn't want to do all of this thing. Okay, I only wanted to find out this part 24. Okay, this 2x over here. All right, this part I wanted to find the length of only this part. So either you could have done what we did over here, or you could have also done with 2, which is this part, divided by the total line, which is 2 plus 3. That means 2x divided by 2x plus 3x, which is the total line, and then you multiply it with 100. Okay, so you'll get what? 2x upon 5x. So this will go away, and you could have done in this way also. Same thing if I wanted to find out only this part, so same thing you will do: 3x, the bigger part, divided by the entire line, which is 3x plus 2x 5 centimeter, multiplied by the total line of the actual centimeter of the entire line. So you could have again gone with this one and gotten the answer as 60 centimeter. Okay, so this essentially goes to show the very basic concept of ratio. All right, now also very basic property of ratio would be that A is to B is not equal to B is to A. Okay, so if I have a 3/4, 3/4 doesn't mean 4:3. Okay, this is like a very basic property of ratio. Okay, now and also when you are saying that two quantities are in ratio, that essentially means that they both have the same unit. Okay, so 2 kgs and 3 kgs. You cannot say that one quantity is in kgs, another quantity is in liters. That will never happen. So whenever you will only get ratios of those quantities which are having same units with them. Okay, so with that, let's look at certain questions based on ratio and proportion. All right, so over here we have Asha, Altreda and Amata had a total of rupees 2,750 with them. They decided to divide this money between themselves such that So now they have given certain conditions such that 1 by 4 of Asha's share. So now since we do not have their shares with us, let's assume that Asha, Alteda and Amata, let's say that their shares are X, Y and Z respectively. Assume it. So then they are saying 1 by 4 of Asha's share, that is X by 4, is equal to 1 by 5th of Atleda's shares, that means Y by 5, and it is equal to half of Amata's share, that means Z by 2. Okay, now it will always be better to get all of this in one coefficient. So like let's take these two first. So I can get this thing in terms of x, the value of y I can get in terms of x, which is y is equal to 5x by 4 by cross multiplication. Same thing when I consider these two. So again I can do cross multiplication and get the value of z in terms of x, which will be x by 2. Right. So now that essentially means that if I want to make an equation, so Asha becomes x, Atleta becomes 5x by 4, and this is x by 2. So the equation ratio will become x 1 by 1 is to 5 by 4 is to 1 by 2. So now I want a straight line equation, right? So again I will use LCM method, right? If I use LCM of all three, which is going to be 4, so this becomes, ratio will become 4 is to 5 is to 2. This becomes my actual ratio. Now the question had asked me how much did Amata receive. Remember I told you if I want Amata is this part. So if I just want to use this thing, so I can go 2 divided by 5 plus 4 plus 2 into the total amount, which was 2750. So this becomes 2 by 11 into 2750, which means the share of Amata will actually be rupees 500. Okay, not a very difficult level question, it's just that how you interpreted this part of the problem over here. Fine. Okay, let's take another question over here. So $9,000 is divided among Harry, Ron and Hermione. The ratio of the amount Hermione got to that of Ron is 1:3. So Hermione share versus Ron's share, the ratio is 1 by 3, and Ron's share ratio with Harry's share is coming out to be 1:2. All right. Now, but the thing is that usually when I have 9,000 rupees as the total amount, which is divided among all three of them, and I'm getting two different pairs of ratio, so it doesn't work for that. Work with that. I will need to convert these two pairs of ratio into one. So if you see, Ron is actually the common link between them, right? So you can use this shortcut over here. Pay attention. You can use this shortcut to transform two different pairs of ratios into one, where one of them is common. So it is 1:3, and write it in this format. The another part is 1:2. So if I want to create one single line ratio, it will be one multiplication of these two, 1:3, then multiplication of these two, that is 2 into 3, and multiplication of these two, which is 1 into 1. So in this way, by writing it in this format and multiplying it like this, first these two, then these two, and then the first two over here, you will get the single line ratio, which will come out to be 1:3:6. So this is the single line equation of Ron, Hermione, Ron and Harry. And now I can easily find out anyone's share now, because I remember I told you the share is actually x, 3x and 6x. So total will be what? 10x is equal to 9,000. That means x is coming out to be 900. I can find out everyone's share now. So Hermione's share would be 900. Ron's share would be 3 into 900, that is 2700. And Harry's share will be 6 into 900, which is 5,400. Okay, so So the key takeaway over here is this: how we can transform two different pairs of equation having one common link into a straight line equation. Okay, let's talk about something very important, like how do we usually compare ratios. So say let's take an example. All right, like I have 4 by 5 and I have 3 by 4. Now if you are like very good with fractions, easily you can see that 4 by 5 is nothing but 0.8 and 3 by 4 is 0.75. So in this case, this first ratio will be greater than second one. But how do, if the numbers are big, okay, and you don't know the actual fraction to percentage or fraction to decimal conversion, then what you will do? So you can do like this. If you have same example, let's take 4 by 5 and 3 by 4. Okay, so what you will do in order to find the which ratio is bigger is that cross multiply. Okay, so on left and write it exactly in this way. So on left hand side it will be 4 into 4, on right hand side it will be 3 into 5. So this value is coming out to be 16, this value is coming out to be 15. So then because my left hand side value is coming out to be bigger, so the left hand side ratio will be bigger. Okay, again let's take some other example. 10 by 7, 9 by or 14 by 8. Okay, so what will happen over here? 10 into 8 is 80, 14 sevens will give you what? 98. Since second right hand side value is coming out to be bigger, that means 14 by 8 will be greater than 10 by 7. So in this way you can compare whenever you there is a need to compare two different ratios. All right. Okay, let's take a look at this question. So two numbers are there in the ratio of 3:5 and the difference of their squares is 64. So find the numbers. So since the numbers are in the ratio of 3:5, I can take the numbers as 3x and 5x, actual numbers. Okay, and then they're saying that the difference of the squares is 64. All right, since we're taking difference, so of course 5x is going to be bigger, right? So 5x square minus difference of the squares is coming out to be 64. So this becomes 25x square minus 9x square equal to 64. That means 16x square is 64. Okay, now this means x square is equal to 4. That means the value of x can either be 2 or minus 2, right? So x, the possible two values of x is coming out to be plus and minus 2. So there will be two different set of numbers that we will get over here, because we cannot discard any of these two values. So the numbers will be substituting in these two equations. All right, so if I put 2, the numbers are 6 and 10. If I substitute minus 2, the numbers will be minus 6 and minus 10. So these are the two sets of answers which I will get for this question. These are the two different set of numbers. Okay, let's take another question. So this question came in your examination, past examination of SNAP 2009. Fine, let's look at it. So they are saying that weekly incomes of two persons are in the ratio of 7:3 and their weekly expenses are in the ratio of 5:2. Okay, so if each of them is saving 300 rupees per week, then the weekly income of the first person is fine. So you need to know this basic formula that savings is nothing but income minus expenditure. Fine. Now I have two different people, right? So let's say A and B. I have their ratio of incomes and the ratio of their expenditures. So the ratio of the incomes was 7:3. So that means actual numbers will be 7x and 3x. and their expenses were in the ratio of 5:2. So let's say since we have already used x, let's say the expenses are in the ratio of 5y and 2y. The actual expenses are 5y and 2y. So if I put it in this savings formula, so their savings 300. So let's talk about A first. So A is saving 300 rupees and his income is 7x and his expenditure is 5y. Same thing for B, it will be this, since he's saving the same amount of money, so 300, so his income is 3x and expenditure is 2y. So this is essentially a simultaneous equation that you have with you over here. So let's take multiply this equation by 2, multiply this equation by 5, so that you can discard this 10y, it will become 10y in both of them, so you can discard that value. So if I solve this simultaneously, I'll get the values of fine, so x will come out to be 900 and y, if x is 900, so 7 is 63, 63 minus 6000 should be, so that means y will actually be 1200. So I have the value. By solving this simultaneously, I can get the values of x and y as 900 and 1200 respectively. Now the question was asking me what is the weekly income of the first person. So I considered the first person as A. His weekly income was 7x. So 7 into 900, 6300. So option number 3 will be your right answer. Okay, the only difficult part over here was to know this format, which is actually very popular formula. Okay, another past exam question which appeared in FMS 2010. So here what the question is saying, that there are two numbers, alright, such that their difference, their sum and their product are having a ratio of 1:7:24. So difference, sum and product, let's take their actual numbers as x, 7x and 24x. Fine, and the two numbers that that are having these characteristics, let's say that those two numbers are a and b. Okay, so since the difference is x, that means a minus b is coming out to be x. Their sum is 7x, so a plus b is 7x, and their product is 24, so a into b is 24x. Right, I can solve these two simultaneously, which will give me 2a is equal to 8x. Alright, because these two will go away, right? So a will become 4x, and if a is 4x, so what can I say about b? B will be 3x, because 4x minus b is equal to x was there, so b will have to be 3x. So I have the value of a and b over here with me now. Alright, let's substitute these two values in this equation. So it becomes 4x into 3x equal to 24x. That means 12x square becomes 24x, so this goes away. X will be 2. Okay, if x is 2, the question was asking you what will be the product of those two numbers. So the product of those two numbers comes out to be 24 into 2, which is 48. Either do this or find out those two numbers individually. 4 2s are 8, 3 2s are 6, 6 8s are 48. Even like this also you could have done and gotten the answer as 48. Okay, alright, so with that let's take a look at proportion now, what proportion actually means. So essentially proportion is nothing but it's an equation where we have two different ratios, where we are equating two different ratios. So it's like a is to b equal to b, c is to d. So it is usually represented in this format: a is to b, then 2 like this to signify equation, and c is to d. So in very basic terms, it is nothing but there is an equal to sign. You are equating two ratios, two different ratios on either side. You are equating them. It's as simple as that. Alright, so what if I have A by B and C by D? So extending this, I can also say that by cross multiplication A into D will be equal to B into C. Okay, so you can keep this as a basic property of proportion aside. So that means, say, how will it be useful is that, so let's just say that you have 3 by 5, sorry, you have 3 is to 5 and x is to 8. So if the question asks you find the value of x, so you can use this format. So 3 by 5 will be equal to x by 8 because it is in proportion. So 24 equal to 5x. Okay. Uh, so that means x will be equal to 24 by 5. Or if you want to get into this thing, so it will be 4.8. Also you can go to. Alright. So in this way the property of your proportion will help you. Let's take a question based on this so it is much more clear. So find the fraction which bears the same ratio to 1 by 27 that 3 by 11 does to 5 by 9. Okay, so what slightly confusing if you read it together. So essentially they want to find they want you to find a fraction which is having the same ratio to 1 by 27. That means, let's say that that fraction is x as of right now. So that fraction is having the same ratio to 1 by 27. Okay, which is that 3 by 11 is having to 5 by 9. So essentially this is how you will represent the statement what they have mentioned from here to here. Okay, so what can you do now? So cross multiplication, so this becomes, alright, so I can get rid of this. So this becomes 1 by 99 as of, okay, and then 5 by 9 is also coming over here. So 5 by 9. So this 9 will go up denominator. So 9 by 99 into 5. So x is coming out to be 1 by 55. So the fraction that they are asking you for, the value of that fraction is going to be 1 by 55. Alright. We use basically again we use the very basic property of proportion over here. Okay, now let's take a look at concept of continued proportion. Okay, now this continued proportion is nothing but like an extension of uh, your proportion concept itself. So in the proportion, if you see, we did this thing that yeah, so in the proportion, if you remember, we said that it is nothing but the it's a way of equating two different ratios, right? So this continued proportion is just a special case of it, an extension where the second and the third proportion will actually be equal. Okay, that means in the previous one we used to have a is to b is equal to c is to d. So in this way there will be a common proportion between these two equations. All right, and again if you this thing, if I go ahead and do this thing, cross multiply over here, so this will give me b square is equal to ac, right? Now if you're aware of something called as geometric mean, so geometric mean is nothing but a an example of continued proportion only. So in the geometric mean also you have b square is equal to AC, right? And this b part, okay, which is being common in these two ratios, it is actually called as mean proportional. Okay, so remember this. So a continued proportion in actuality, it is nothing but a extension of continued proportion where there is a mean proportion given to you. That means there is a common proportion between those two ratios, and when you go ahead with that, it will give you a formula of b square is equal to AC, which is nothing but your GM's formula, that is geometric means formula. Okay, let's take a question which is based on this concept. Okay, yes, so we have this question that three numbers are in continued proportion. Their mean proportion is 10 and sum of the other two is 29, and we have to find the numbers. So since three numbers are in continued proportion, so let's just say that those three numbers are A, B and C. Fine, and their mean proportional is 10. Now remember, if I'm taking A, B and C in continued proportion, so this means my B will become the mean proportion, and they are telling me that mean proportion is 10. Fine, if my mean proportion is 10, I have the formula of this thing, continued proportion is B square is equal to AC. So by substituting the value of B, I'll get AC as the product of A into C as 100. Right? Apart from this, I also have this piece of information that apart from the mean proportion, the sum of the other two numbers is 29. So that means A plus C is going to be 29. Right? So, and now I have to find the numbers, all the three numbers. So how can I do that? I only have these two equations to play with. Okay, so let's see what we can do over here. Fine, so let's say that this C is, I'm representing C in terms of A, so that I can substitute it in this equation. So then I can write it as A plus 100 by A equal to 29, right? This will become A square by 100 divided by A equal to 29, which means A square plus 100 equal to 29A. This is because this is giving me a quadratic equation. So my quadratic equation is coming out to be A square minus 29A plus 100 equal to 0. So just by looking at it, you can make out the factors. The factors are going to be, since this is plus over here, the factors are going to be 25 fours are, right? Minus 25 minus 25 minus 4 gives you 100, and then the addition of them will give you minus 29. So A minus 25, A minus 4 equal to 100. So the value of A is coming out to be either 25 and 4 over here. Right, now since I cannot discard any of these two values, that means again over here there will be two different pairs of answers for me. Fine, so because they wanted to find out the numbers, if I take the value of A as 25, okay, if I take the value of 25, C will have to be 4, right, because 25 plus 4 by substituting over here. If I use the value of A as 4, then C will have to be again 24 plus 25. So that means those two numbers, after that, since we did not actually have to find out the value of B because B was already given as 10 to us, so the values for those three numbers are either 4, 10 and 25, or 25, 10 and 4. So two different pair of answers are available for this question. Okay, okay, now with that out of the way, let's look at the concept of variation. Okay, now this is something that we have done to some capacity in our colleges and school. Now remember, let's say the formula for speed is equal to distance upon time, right? So if I keep my time constant, okay, let's say that my time is constant. So what can I say with the relationship between speed and distance? That speed is directly proportional to distance, right? And what does this actually mean, that speed is directly proportional to distance? It means that if I keep on going increasing my speed, okay, if I keep on going increasing my speed, my distance will also increase. If I keep on going increasing my distance, my speed will also increase. That goes to shows that. Now there is also, if I now keep the distance common, all right, if I mean over here it means essentially that if I increase my speed, I will be able to cover more distance. All right, now if I keep my distance constant, all right, so what can I say about speed and time? Now I will be able to say, if my distance is constant, that there is an inverse relationship. This is directly proportional, this is inversely proportional. That means if I increase my speed to cover a particular distance, then I will require less time. If I increase my speed to cover a particular distance, I will cover that distance in lesser time. Same thing, if the time is increased, that means my speed was less to cover that distance. So you have to understand that in directly proportional, if one thing is increasing, it is also causing an increase in another one. In inversely proportional, an increase in one thing causes the decrease in another one. Fine. So there are many things like this, like price and consumption also have directly proportional. So if your price increases, price and this thing, consumption have inversely proportional. So if your price of a particular commodity is increasing, you will use less, consume less of that commodity. So this is essentially the meaning of your variation. All right, now remember that if it is directly proportional, I used to introduce something like k over here. So this k is nothing but constant of proportionality. All right, same thing over here. So I will introduce k over here as well. S is equal to k by t. All right, how this k, introducing k, actually helps me? So usually a very typical type of question in variation will have two different scenarios. Okay, so in one scenario they will give you all of these values, s and t, both of them. So using that you will be able to find out the value of k. And then in the second scenario, again they will give you speed but they won't give you time. So in that case, since this k was constant, so you can use this value of k over here to find out that unknown value. All right, you'll understand when we look at the next sum, so how we can use the value of k. But understand that in directly proportional, you will introduce k as constant of proportionality, so something it will look like this. And in this thing, inversely proportionality, you will use constant of proportionality k over here, and it will look something like this. All right, now there is also a possibility that two things are happening. So let's say that the gravitational force formula is directly proportional to your product of the masses, and it is inversely proportional to the square of the distance. It is similar to like over here, the speed is also directly proportional to distance, and it is inversely proportional to time also. So if that is the case, you can always club them like this. All right, let's take a look at an example so that we can understand it better. Okay, so they're saying that if 10 kg of sugar is costing you rupees 200, then what is the cost of 12 kg sugar? So it's like very basic, just I have taken this question just to make you understand. You can do this in another way also, but how can we use variation, how variation will come into picture? Let's look at it. So now see, of course, your cost will vary directly with your quantity. Okay, that means higher the quantity, higher the cost, right? So I can make a equation like this. Sorry, cost is will be equal to K into Q. Fine. Now initially I have the cost as 200, K is not known, quantity is known as 10 kgs. So the value of K will come out to be 20. Then in the second scenario, I have the cost. I don't have the cost with me, but I have the quantity which is 12 kg. So again, I can use this formula, but in this scenario, I have the value of K with me from over here. So I'll substitute it over here to get it. So the cost of 12 kg of sugar will actually be 240 rupees. Okay, you could have done this using basic unitary method also. All right, but then I just wanted to introduce how you can do this with the help of variation. Okay, let's take a question which actually came in exam. So yeah, so this is from CAT 1999. Read the question properly. So we have over here that the speed of a railway engine is 42 km per hour when no compartment is attached, and then the variation relationship is coming over here, that reduction in speed is directly proportional to the square root of the number of compartments attached. That means if I want to write it, so reduction in speed, so let's say speed is S. Okay, so reduction in S is directly proportional to square root of the number of compartments attached. Square root of the number of compartments attached. So this is my relationship established. So then the question is saying that if the speed of the train carried by this engine is 24 km per hour when 9 compartments are attached. So initially the speed was 42, and in the second scenario it is 24. So remember, it is not the speed is not directly proportional to your square root of number of compartments. It is a reduction in speed which is directly proportional. So that means your speed reduced from 0 compartments when it has 0 compartments and when it has 9 compartments. So the reduction of the speed is 42 minus 24, which will give you 18. Reduction in speed becomes 18, and then this can be written as is equal to K, right? We will introduce constant of proportionality, and then it is square root of 9 because 9 compartments were attached. So the value of K will be what? 18 by 3, which is 6. Right? Now, so that means I can say that reduction in speed is equal to 6 root n with this equation. Now the question is saying then a maximum number of compartments that can be carried by the engine is, okay, slightly twisted, okay, over here. Now remember that maximum number of compartments can be carried out by the engine when the speed will be reduced to its minimum, right? Because if your speed is going to reduce with the increasing number of compartments, right? So the maximum number of compartments the train will be able to carry when the speed is minimum. All right, so your actual speed is 42 and your minimum speed is 0. So reduction in speed is 42 minus 0, and it is equal to 6 into maximum compartments. Okay, I have made this equation specially for carrying maximum compartments. So remember, for carrying 9 compartments the speed was 24 km, and for carrying maximum compartment the speed has to be the most minimum, which is 0. So I made this thing. So I have it like this: 42 is equal to 6 into maximum, I'll write it C max. Okay, so that means root of C max is equal to 7. Alright, so I can essentially write this thing as 7 over here. That means if I square it on both sides, the maximum number of compartments is 49. Alright, so now hear me out. If when 49 compartments are added to the engine, the speed of the train is reduced to 0, right? So that means the train is not moving at that time. So hence the maximum number of compartments that can be carried by the engine when it is moving is just one less than that. So when the train will be carrying 48 compartments, the train will be moving, all right, it will be a very slow speed, but it will be moving. But when I add one more compartment, 49, the train will stop. So that's why I first found out the maximum number of compartments when the train will not move at zero speed, and then just remove one compartment, because if I do that, then the train will move with the maximum number of compartments and it will carry it. So the answer over here will not be 49, it will be 48. Okay, very important conceptual part over here, starting from this side. Okay, so I hope the entire this thing, this question was clear to you guys. Okay, and so yeah, so this is essentially we have covered concepts, uh, questions, and past examination questions from ratio, proportion, and variation. So I hope that you have some clarity on all these topics. So if you like the video, so please subscribe and like and subscribe to the channel. Okay, and you can also share it with some of your friends so that even they can get their concepts cleared. Also, you can try following us on Instagram, so to get regular updates about the videos. All right, thank you so much.